All right, let's continue. This part of the video, this video is going to be really important. Measures of central tendency. So here, measures of central tendency are various measures that can be used to indicate what would be representative of a typical piece of data in the set. Okay, just a single number that's supposed to represent a typical piece of data in the data set. So you know a lot about, probably know a lot about all of these, or at least the first three, but a mean is what you typically do to get your like average in a class. So like the mean of your test grades would be just adding up all the values that you have and then dividing by how many values there are. So adding all the values and dividing by the number of values. That's the mean. The median is where a lot of mistakes are typically made. It's also can be a number that represents the middle, you know, a number that's supposed to be representative of the data set. But this is the part that people sometimes forget. You need to first rank the values. That means put them in order from smallest to largest. And then the middle value would be the median, sorry. The middle value would be the median. Now here's the deal. If you have an odd number of values, and you'll see an example in a minute, if there's an odd number of values, the median will be the middle value in the list. But if you have an even number of values, there is no middle. You would have to take the two middle values, okay, and average them. So you find the average of the two middle values. So this is the one to work on. People mess this one up a lot. And then the mode is one that just tells you which value occurs most frequently, which one occurs with the greatest frequency. And some data sets might have more than one mode. They might have two most frequently occurring values, and it would be considered bimodal. Okay. So typically, if no value occurs more often than the others, or if you have like a whole bunch of the data values occur twice, then you would just say that it has no mode. Okay. And then the mid-range might be unfamiliar to you. That one's not as common. For that one, you just average the lowest and the highest data values. So mean is what you typically do to figure out like what your average test grade would be for a class. Median would be the middle number. Mode would be the value that occurs most frequently. And mid-range you would find by just averaging, just adding the lowest and the highest and dividing by 2. So we're going to do that for these two data sets. We're going to find the mean, median, mode, and mid-range for each of these. Okay? So I'm going to try to squeeze it in over here. No, maybe not. I'm going to go ahead and give myself a little more space. You don't have the room on yours, but I'm just going to open this up and give myself a little more room. So let's do that for this data set. So the first thing you'd want to do is put these in order. So smallest, if you're doing all four. So if you have to do the median or the mid-range or the mode, it helps to get your data in order. Now, if we were doing this, we could use technology typically to help us with this, to sort the data and get it in order. And that would help you to see which one occurs most frequently. It would help you when you try to calculate your median, okay? So I'm just taking the data sets, looking at them, getting them from smallest to largest. Now, I didn't need to do that to calculate the mean. So for the mean, I'm just going to add 15 plus 62 plus 69 all the way up to the 95. And when I'm through, I'll hit enter and divide by 2. Not 2. Divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry. Divide by 10 because there's 10 in the data set. And that top part, when I add them all up, was 750. So dividing by 10 means the mean would be 75. Okay. Right, for the median, what I would do is put them in order if I hadn't already, And since there's 10, see how there's 1, 2, 3, 4, 5 low ones and 1, 2, 3, 4, 5 high ones. There's no one number in the middle there. So what you would do for this one is you would take the 2 that are in the middle, take the 78 and the 85, and average those. So add those up and divide by 2. And if I did that, that would turn out to be 90. So the median would be 90. All right, now for the mode, I'm just going through my data set and I'm looking for the one that occurs more than once, if there is one. So here are 2 90s, so the mode of this data set would be 90. Okay. And then for mid-range, that's the one that's the least familiar typically. What you would do for the mid-range is you would take the lowest and add to that the highest and then divide that by 2. So for the mid-range, I would take the 15 and the 95 and add that up. That'd be 110, right? 110 divided by 2, and that would be 55. So any one of these could have been thought of as in some way representative of the data set. We'll talk about why you might use one over another one later. Okay. All right, I want to go ahead and do the same thing for this one. You should stop the video and try it and then just check and see if you're thinking right. So I'm going to do the same thing for my mean. I'm going to do the same thing to find my mean, my median. Then I'll come over and do the mode and the mid-range. Okay, so to do that, I'm going to put them in order. So you should have done the same. There's a 75, 77. I'm trying to get them in order. 78 and 80. Okay, then another 80, then an 85. Okay, then a 90, a 91, and a 94. I usually count. So there were 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 13. I think I got them all. All right, so for the mean, it didn't need to be in order for me to do this. I would have just added up all of these through the 94 divided by the 13. And on that one, we wound up having 1,022 divided by 13. And that turned out to be 78.6. And I don't know, that was probably rounded, so I'll do a little squiggle. 78.6, okay? For the median, if there's 13, then notice how there'd be 6 low ones, 6 high ones. It helps to think about this. 13 total, right? So 6 at the bottom, 6 at the top. So then there is a middle value right there. So I don't have to average anything. The median would be that middle value, that 78. See how that was odd? So that's why that happened, where this was even here. So that's why I didn't have one middle value, since there were 10 total, and how that was even. That's why here I had to average to get my median. Right now for the mode, once I put them in order, I could see that 80 was the mode, and the mid-range is now easier to do because I can find the low and the high at a glance and just add those and divide by 2. If I did that, I'd wind up with 19.5. That seems way too low. That's not right. I didn't bring, that's not right. Let me try that. I think I just wrote that incorrectly. So it should be more, we got 159 divided by 2. So yeah. So that turns out to be a 79. That makes more sense. 79.5. Okay? And any one of those could be considered as representative of the data set. I feel like the mode seldom gives you a very good idea. And I feel like the mid-range, that's really only considering the lowest and the highest. And so that one can also be a problem. And then there are reasons why the mean versus the median might be a better measure to use, okay? So for these two classes, I think the key idea I want you to have, to know, is this right here. See how low that is compared to all the other values? That's why when you look at the, well, that doesn't seem right. That's not right. I'm glad I went back. I was going to say that's so much higher. I didn't expect it to be that high. I had just looked at the wrong place when I wrote it down. So let me fix that. 78 plus 85 divided by 2. That should have been just 81.5. Okay, so make that correction. I just wrote the wrong thing when I was looking at my scratch work. But do you see that really low 15 right there? Okay, that 15 is included when you do the mean and you wind up adding everything and dividing by 10, and that 15 is so much lower than all the others. That's why that mean turned out to be so much lower than the median, because that low value of 15 really, sometimes they use the term skews the mean. It brings it down because it was included in that, where the median is just the middle number. So that 15 that you saw there could have been as big as 80, and your median would have still been 81.5, right? So that 15 really didn't matter so much with the median, is the point I'm trying to make. Now, when you look at Class B, all the grade, if you look at the grades, all the grades range from like a 65 to a 94. So they were closer to each other. You didn't have any real extreme values. And so when you look at that, see how the mean and the median turned out to be similar in size? That's why that happens, is there's not a really low or a really high value that would have affected the mean. So when I asked about determine the mean, median, mode, and mid-range, you need to know the definitions and be able to do that. But then if I say which might be better for each class, I think for Class A, so for A, the median would have been better, because the 15 skews the mean, affects the mean. And I think for B, I would have used probably the mean or the median, both of those. I don't think in that case the fact, like the mode, I mean, that's just in each class that only occurred twice, so it's not like it's that meaningful. And the mid-range gives you a quick sense, but it's only using 2 values. And notice on the mid-range for Class A how 55, I don't know, that really doesn't seem to represent the data set very well. And on the second data set, it does a pretty good job, but that's because those data values were already pretty close together. Okay. All right, now let's go ahead and look at another style of problem. So here we have data that's been organized in what we call frequency. We have the number of people receiving each salary. So what we see over here is how often these numbers, or how often a particular salary occurs. So if you want to compare it to what we did before, it's like we have one data value that's at 974,000. Then we have 2 at 85. Then we have 2 at 68. And I could continue this idea and just make a list of all of them. But there's a lot of data values, and I really don't want to list that 53 6 times. But can you see it would have occurred 6 times there? So there's 6 of those, 2 of those, 2 of those, 1 of these, and so on. So that's how this varies from the other way of representing things. And when you have more than just a couple of data values, this might be a good way to to show things, to put it in a frequency table. So then the way you might calculate the mean, the median, and the mode feels a little different. You're still defining it the same way, but you just have to understand logically why this would make sense. So if I'm trying to do the mean, I need to add up all these data values, and there's not just these 6, right? There's really 1, 2, 3, 4, 5, 11, that would be 15. There's really 20 data values. And if I wanted to, I could sit here and list them all, right? I just didn't. There'd be 4 of those, and then 38,000 would have occurred 5 times. And I could have listed them all, and then I could have typed them all in and added them up to get the total of all of those. But a quick way to do that might be just to multiply the frequency something occurs by the salary. So 85,000 occurs twice. If you do 2 times 85,000, that would be 170. If you do 2 times 68, that would be 136. If you did 6 times 53, that would amount to a total of 318,000. So like if I added up all 6 of those, that would be 318,000. But rather than typing all that in, I'm just going to do 53,000 times 6, 45,000 times 4, and so on, and get those intermediate totals. And then I'm going to add all those up, and I only have to type in those 6, and I would get this number. So that's the total of all of the salaries for all 20 of those people. All right, so now if I'm doing the mean, I've already added up all of the salaries for all 20 of those people. And even though you're only seeing 6 here, you only have 6 different salaries. That's really the total for all 20 people. So you need to divide by 20, and you come up with the mean annual salary being $98,400. For the median, you need the middle number. So that's when these frequencies become helpful. So what you would look at is if you had 20, you got to count 10 from below, which would put you in this category, and then 10 from above. 1, 2, 3, 4, 5, and 5 more would get me to 10. So I'm going to get to the last one in this category, and that would be 53,000. So 53,000 would be the median. Okay. Now for the mode, you would look for which one occurs most often, and you have that. 6 tells you that the mode would have been 53,000. Okay. All right, and then for mid-range, these are in order, right? So you know the lowest was 38,000. The highest was the 974,000. You're going to add those up, hit enter, and divide by 2, and that gives you 506,000. Now, looking at and thinking about all 20 of those salaries, which of those numbers really better represents or is most representative of the salaries at this company? I don't think 98,400 is very representative. Oops, trying to get the comma in the right spot. It's very representative of it. If you look at that, 19 salaries, these 19 salaries right here are less than that. Even though 98,400 is technically the mean, there are 19 salaries that are less than that. Okay, the median and the mode both turned out to be 5,300. I feel like that's way more representative of this list, if you can picture that list of salaries over here to the left. Okay, the mid-range, mid-range turned out to be 506,000. Okay, I mean, that's not representative of the data set at all. All right, so here was a question that said, is the company's claim technically truthful? So what they're talking about is back here. They said, up in the statement, George finds a flyer in which the company advertises that its average employee makes about $100,000 a year. Sounds pretty good, so he accepts an entry-level position, betting on advancement in the future that would get him at the average. Okay, so looking at this, was there anything wrong with them claiming that the average, sorry, I'm trying to get it to do what I want. All right, so it doesn't seem unreasonable for them to have made that claim. If you look at the values we got, their claim was that average employee makes about $100,000 a year, and the mean turned out to be almost $100,000. So technically truthful, I would say, since the mean was 98,000, what was it, 400? 98,400, which is almost 100,000. However, it feels deceitful to me since only one person makes more than that. Okay. So I would say the median would be the best one to use, since the one really high salary affects the mean, makes it higher, pulls it, skews it upward. Okay. Also affects the mid-range. So both of those are out. I think you could say mode or median would be the best. Of course, they were both 56. The mode in this case might not be a bad idea, because you're really telling people what most people at the company make. So I think you could argue mode or median on that one. Okay. These are kind of opinions, but the big idea is to look for extreme values in a data set.